Hi, welcome to this lesson on calculus, the factor and remainder theorems. Let's have a look at the remainder theorem now. So the remainder theorem will help us in factorizing a cubic function, which is our main goal in order to analyze cubic functions. So before we get into the theorem, let us recall how division works with natural numbers. So let's say, for example, if we divide the number 26 by 3, then we will have 8 copies of 3 with a remainder of 2. So this is represented as 26 is equal to 3 amounts of 8 plus 2. So 26 is the dividend, 3 is the divisor, 8 is the quotient, and 2 is the remainder. So this is the algebraic way of representing the polynomial long division, or natural number long division rather. So if we have 3 dividing into 26, that can go 8 times 3 is 24. Subtracting them, you have 2. So 8 remainder 2. So algebraically, this is represented as 26 equals 3 times 8 plus 2. So the remainder theorem is the following. If p of x is a polynomial that is divided by cx minus d, so this polynomial is being divided by a linear polynomial, cx minus d. Then the remainder is given by the polynomial evaluated at d divided by c. Okay, so it has to be in this form, cx minus d. That's the crucial part there. So let's have a look at an example. If p of x equals x squared minus 7x plus 12, and we divide it by 2x minus 2, then we can automatically know what the remainder is. And it's going to be p of, so here's your c and here's your d. So d divided by c is 2 divided by 2, which is 1. Okay, because I'm already separated by a minus sign here. So p of 1, so I need to evaluate the polynomial at 1. So it's 1 squared minus 7 times 1 plus 12, which when evaluated gives me 6. So I know that when I do x squared minus 7x plus 12 all divided by 2x minus 2 is going to equal some other quotient polynomial q of x plus a remainder of 6 over that 2x minus 2. Okay, so we can actually verify that the remainder is 6 by using polynomial long division. So yeah, we set it up. What do I need to multiply 2x minus 2 by to get rid of that x squared term? Well, if I multiply by half x into here, I get half x times 2x gives me x squared. And then half x times negative 2 gives me negative x. X squared minus x gives me 0x squared. Negative 7x minus x is negative 7x plus x. So that gives me negative 6x. And I can bring down the 12. And then if I multiply negative 3 into that divisor, I get negative 6x plus 6. So the negative 6x minus the negative 6x will give you 0x. And 12 minus 6 gives me 6. And that is the remainder. But that's really great because we actually saw by the remainder theorem that that is actually going to be equal to 6 in advance without even having to do any of the polynomial long division. So your quotient function q of x here turns out to be a half x minus 3. And then the leftover part is the remainder 6 out of your divisor part, 2x minus 2. All right, so that's the remainder theorem. Why do we need it? Well, we're going to use the remainder theorem as part of the factor theorem. And then the factor theorem is the final one that helps us to factorize cubic polynomials. All right, so let's have a look at some practice questions using the remainder theorem. I'll see you in the next one.